Alright, in this short little video I'm going to introduce the idea of optimization and the numerical methods that we're going to be talking about, the optimization methods. And just to get started, first thing I want to talk about is just the basic objective of optimization. So when we're trying to optimize something, the way that we talk about that in mathematical terms, we're looking for extrema of functions. So we're looking for maxes and mins of functions typically. So I'm just going to write this down here. So the objective of optimization is to search for a maximum or a minimum of a function. So that's just it's a simple definition. It's probably a little over-constrained, but it's the definition we're going to go with for now, and the main objective of optimization. So we can think of it as if we have some one-dimensional function, say it's a function of x, and this function might have something that looks like this. And we would say that this function has a local minimum here and a local maximum here. And so this is a max and this is a min. And so when I say we're going to search for a maximum or a minimum, I'm talking about finding these extreme points. And the way that we found these in calculus was we took the derivative of our function and found where it was equal to 0. And that was where the extrema were. So that's points where the derivative are equal to 0. And those typically correspond to max and mins. Now, as engineers, why do we want to find max and mins of things? Well, just talk about the motivation here. Motivation for doing optimization in the field of engineering. Engineers are often tasked with finding the best result. So engineers are often tasked with finding the best result. This is usually reflected in design. So we want our design to be the best possible design. So best here is kind of, haven't really defined what best means yet, but we might think of best as in being the lowest cost in dollars, you know. Maybe the best performance, so highest performance, maximum efficiency, having a hard time spelling here. Maybe for a specific system that we're designing, we want to find a minimum operating temperature, just trying to give some examples here of why we want to find maxes and mins in engineering. So, I mean, just we can think of some more concrete examples. Maybe we're tasked with designing a tank or a pipe or a duct, I should say, a duct. Let's say a duct, and it has some width here, and it has some water in it. So this is water in here. Okay, and the way it's designed, it has some angle here and some length here. We might say, okay, our design has this layout, but what values of L and theta, what values of L and theta are going to minimize surface area. So this water has to flow down this pipe, and it's going to lose energy at where it comes in contact with the walls of the duct. And we want to minimize those frictional losses so our pumps don't have to work as hard. And so we might want to design this pipe such that it has some constant cross-sectional area, A naught, like this, but such that it minimizes the amount of surface area that the water touches the duct. That's just one example. Another example might be maybe we're tasked with designing a tank, and I'll actually do this problem later. So maybe we're tasked with designing a cylindrical tank that has to have some volume of fluid, V naught. Well, we could say it's some number of gallons or cubic feet, and we have different materials. Maybe the top has a certain cost, so a certain cost in dollars. The side has a different cost in dollars, and the bottom material has a different cost in dollars. What can we do to build this tank such that we minimize the overall construction costs of this tank? So how do we minimize construction costs? So the point is all of our problems that we're going to deal with in optimization, we're going to have to put them into some mathematical form. So one of the things that we will have to do, sorry about this thing is wigging out here. So put problem into mathematical form. So that means we need to describe some function, which we'll call the objective function. Describe objective function as a mathematical equation, as a mathematical equation or function. I guess I should say function. Mathematical function. That's the function that whose optima we're going to look for. So we're going to try and find the objective function's maxes or mins. And then we might have some constraints. So we might have some constraints. Such that, like for example, our tank, we said, was constrained by it had to hold a certain volume of fluid. Or maybe our duct had to have a certain cross-sectional area to allow a certain amount of fluid to flow down it. So constraints have to be must be represented as mathematical equations. All right, so we're going to talk about several different types of optimization, and kind of the main types of optimization I've been describing here is constrained optimization. But let me just write down types of optimization here. So I'm talking about different types of optimization. Okay, we're going to talk about unconstrained, so one-dimensional, 1D, unconstrained, constrained optimization, and that is chapter, I think it's chapter 13 in the book, chapter 13. So this is chapter 13 in the text. And then we'll also talk about multi-dimensional optimization. So multi-dimensional optimization. So now we're talking about multiplying functions of several variables. So our objective function maybe isn't just a function of x, but x, y, z, and other things. Okay. So this is, I think, chapter 14. Chapter 14 of the text. And then we're going to talk about constrained optimization. Constrained optimization. And that is in chapter 15 of the text. So chapter 15. So this is kind of the ultimate objective, is to be able to do constrained optimization in several dimensions. But we're going to start with the easy case of one-dimensional unconstrained optimization first, explain that, then explain multi-dimensional unconstrained optimization, and then we'll jump to constrained optimization with multiple variables. Alright, I think that does it for the introduction. The next video I will talk about one-dimensional unconstrained optimization.